Zoom. All right, so today is May 26th. As I said, we're going to be going over Python fundamentals. Some of you guys have coded in Python before, which is great. Some of you have maybe never written a line of code in Python. It's totally okay. From my experience, I learned Python fairly recently. Again, I think it's very developer friendly, just easy to use. There's a lot of stuff baked in, as in like libraries and stuff, so you don't necessarily have to always download third-party libraries. I think again, it's very easy to kind of understand. If you know JavaScript, again, it shouldn't be too difficult to kind of pick up Python. So again, the next few I guess days or even weeks, you're gonna be doing challenges both in JavaScript and Python, just to make sure you understand both, understand the similarities and differences when you're coding in both. If you notice when I was coding on screen, there's a few times where I started writing print instead of console.log. Print is the way to kind of output in Python. So it is possible to get confused, especially when you're working with both. It can be frustrating at times, but again, kind of the hassles of learning two languages at the same time. But otherwise, you guys should be pretty good with it. So let's dive into our lesson then. Let's write our first Python app. So I'm going to open a new file. So Python files have an extension of .py. So I'm going to call mine hello.py. Notice that my icon changed to the Python icon. That's from one of our extensions that hopefully all of you guys installed from day one. But yeah, so let's write a Python file. So the first thing I'm going to do is create a greeting. It's kind of going off the curriculum. Variables in Python do not need a let. So I think the best way to go about this might be to do it side by side. Let's create a new file, call it hello.js. All right, so on my right side, I have my JavaScript going, and then left side is my Python file. So let me actually swap those, I apologize. Swap those, all right. So again, left is JavaScript, and then right will be Python. So if I'm writing a simple JavaScript file, I'm going to create a greeting. So let's call it a variable called greeting. Have that be hello Oscars. And then to print that out, I do a console.log of greeting. All right, so pretty straightforward. Hopefully you guys are familiar with this. In Python, again, we don't use these lets, const, or var keywords. You just create a value and assign to it. That basically creates a variable, and again, we'll assign a value to it. So in JavaScript and other languages, you get to specify that you're creating a variable here. Python's a little different in that case. It's just, Python, again, is a little developer friendly. It's meant to be quick, as in just pick it up and develop quickly with it. Okay, so we have a greeting. In Python, we use the print function and otherwise pass it to variable, so greeting. All right, there we go. So if I bring up my terminal and give that a go, let's see, if I do a node for my hello file. All right, we get hello Oscars. And then for Python, you want to use Python and then the file name. So do hello.py. So you get the same output because they have the same greetings, but let's just say from Python. Just distinguish those. So, all right, there we go. One thing I want to mention now, if everyone's coding along or has a screen up, type in Python -V and hit enter. And then you should take note of what your output is. You want to look at the version that you're using. For some people, and when you do Python -V, you'll see probably like a Python version of 2.7. That's an outdated version that we don't use for development. That is a version that your OS is using. For Macs, they use an older version of Python. So just be aware of that. If that's the case, you should be able to use Python 3 as your command. So in our documentation or challenges, we might write like a command of Python. Just be aware, you can always use Python 3 if that's been installed, and then that version should be correct. So in this case, my Python and Python 3 point to the same application. But if yours does not, just be aware, always use Python 3, because that's going to be your modern, or just your upgraded Python version. Any questions on that? Just again, that's been some difficulty some students have ran into in past cohorts. Just want to make that clear that you want to make sure you're using the right Python version. Else you'll get some odd errors and you'll be like, I don't know why this is happening. Okay, so continuing on, let's go back to our curriculum page and grab a little more detailed example. So JavaScript, we have some code there, and Python, we have it here. Okay, so notice both of these are doing the same things. There's just some syntax differences you guys got to be aware of with Python. So instead of the function keyword, we use the def, or definition keyword. So that's what def stands for. But otherwise, it looks pretty much the same. A couple things that I also want to mention. So in JavaScript, blocks of code or scope are created with curly braces. In Python, that is not the case. There's no curly braces to create scope. So the way it's done in Python is by actual white space. So we use tab characters to create new blocks of code. So if I highlight this portion, this is a block of code because it's indented to the same level. All right. In JavaScript, we use curly braces. Now, so one good thing about Python is that it forces you to kind of have nice white space or indentation. In JavaScript, that's not necessarily mandated. So for example, if I wanted to screw up my JavaScript here, I could totally have like, weird indentation. This is not something I would want anyone to do, but it is possible. And, I got my braces all mismatched. So this isn't the easiest to read, but it totally will work. If you try to do this in Python, you will get a bunch of errors. It'll say like, wrong indentation, or, cannot identify the correct block. But again, this is not good practice in terms of you want your curly braces to line up, you want your ifs and your appropriate blocks to be indented correctly, but it's optional in JavaScript. In Python, it's mandatory.
Isn't there a command in that program to fix your indentation?
In VS Code, there probably is either an extension or a built-in command that will auto-indent stuff for you. So I'm going to say that likely exists. I don't know it off the top of my head, but definitely something easy Google can find you the extension or the command to do it. But let me get rid of all those ugly changes because I want my code to be readable. All right, so again, just left and right, same logic is being done, just different languages. So notice we got to use our let in JavaScript, but in Python, you do not know how to do that. Let's talk about blocks of code. So we talked about indentation. To create, for ifs, we need a colon. So we're going to get into if statements. So we have this colon that creates the end of the condition and the start of the body for the if. Else, again, same thing. Kind of just notice differences here. Print statements instead of console log. We kind of went over that. Otherwise, there's not too much different, right? You still have a function, you have parameters that you pass in. You can have comments, so comments are hashtags instead of double slashes. So comment here versus comment here. But otherwise, again, same functionality, just different syntax. Any initial questions on what Python syntax kind of looks like? All right,
looks like when you start a comment, it goes to the end of the paragraph.
Sorry, say that again, John.
The comment on the print line is a hash there, and then the comment continues through the end of the block.
Yeah, so that's because my code is wrapping. So if I actually extend this out here, it's going to come back to the same line. It's just I'm running out of space horizontally. So that's why you might see a lot of wrapping since I have a split screen here. But yeah, usually everything needs to be on one line. So that's another key difference. So if I do something like this in JavaScript where I do let num, or let's let y equals 8, this is totally fine. I create a new line for no good reason, but JavaScript will be okay with this. If you try to do something similar in Python, so let's actually prove this. So if I do, what is it, node, hello, oops. All right, so this totally worked. I got 9 is greater than 5, 2 is greater than, or less than or equal to 5. Yep, that makes sense. Again, this is totally valid syntax. It's not the prettiest, you shouldn't be doing this, but it's allowed in JavaScript. If I try to do the same thing here, like I create a y equals 8, that's not gonna work. Like I got these red lines already telling me something's wrong. If I try to run this, Python hello JS, no, not JS, Python. Yep, so it's pointing me to that line. So line 8 has an error on it, which is because I created a new line. So you can't arbitrarily create new lines in Python. It's pretty strict, but that strictness is for your benefit. It makes your code more readable and is just kind of easier to parse for anyone reading it. You can, if you do really want to like add stuff to new lines, you could use a backslash. And this will basically just say it's going to a new line. Actually, this works for strings. I'm not sure if this will work here. Let me try it out. Yeah, that didn't work. Backslashes do work for certain cases. I guess in this case, it's not going to work, but I will show you guys using backslashes in certain cases. All right, so that was our simple example. Again, JavaScript on the left, Python on the right. Let's actually just focus on Python. So I'm going to get rid of our split screen here. All right, let's actually get into the more interesting parts. We have variable types. So let's copy this over. As noted, when you're creating variables, you do not have to specify the type or use a let keyword or anything like that. You just create the name of the variable and assign to it. It's that simple. You can have global variables. Global variables just sit outside of any function or any block of scope or any scope. So in this case, my sum bar will be a global variable that's accessible anywhere in this file. You can have, so you may want to declare constant values. I guess the common style for that is using all caps for your variable. However, in Python, there's no real concept of a constant value. So if I did want to change my constant bar here, I totally could. There's nothing that's going to stop me. So I do const bar equals, b. That's going to be fine. Nothing in Python is going to know that I want this value to be constant. So just as commonplace, we use cap values for a developer to know that, hey, this value should not be modified. And we probably want to name it with like const in the name, make it clear that that value is meant to be the same. Again, in JavaScript, you could use the const keyword so that if you actually try to change a const value, you would get an actual error. So you won't be able to do it. Just be mindful of it that you can't actually have constant values, but the common way to do it is using all caps for the name of your value.
Quick question here, Ankur. Would you do the same thing with tuples, or would you just use the regular snake case?
For tuples, are you saying the naming for it?
Yes.
Guess I'm not quite sure what the question. Like, yeah, for whatever variables you're using, I guess maybe that's something I glazed over. Yeah, I probably should have highlighted that. Just naming wise, use snake case in Python versus in JavaScript you use camel case. So just to highlight that, in our JavaScript you use, again, you're not using underscores here. For every word you capitalize the new letter of the new word. So that is called camel case. This is for JavaScript. Again, this is style conventions. You don't have to do it, but it's highly recommended that you follow conventions just because everyone else is doing the same thing. In Python, we use something called snake case, which is basically each word is separated by an underscore, and then we just use lowercase pretty much in all cases. Sorry, Reno, I don't know if that was your specific question, but in terms of variable naming, yeah, you generally want to use snake case, but if it's a tuple or a list or whatever, you can name it the same.
Hey, Ankur, I have a question.
Yep.
Are we supposed to be coding along with you?
It's totally up to you. So all this is on our curriculum page. For the most part, most lectures, we don't recommend trying to follow along because generally the pace is really quick. If you do want to try to code along, you're welcome to. But I would say for the most part, this stuff is basic enough where I just want to talk about the key points. So I don't think there's going to be too much benefit coding along in this lecture. But thanks for asking that. Yeah, we'll try to specify when we do expect or want you to code along for your benefit versus most of the times we kind of just want you to follow along here. Sorry, visually, follow along visually. Okay, so we have variable types. We can have local variables. Local variables are confined to your scope. So again, scopes are defined by indentations. So everything I've highlighted here is the same scope. So I have local variable created in my function here. This is accessible anywhere inside my function, but not outside my function. So notice if I tried to print out local var on line 17, I would get an error because local var only exists within my function here. So inside my function, my func, I can use local var as much as I want. But once I get out of that function, that local var is no longer accessible. One thing to note, you can create a variable inside of another scope. So in this case, I'm creating other local var inside of an if block, but I'm using it outside of that block. That's actually totally fine in Python. Most languages will require you to create a variable in that block. So most, like, you want to create your value here, and then you could use that inside here and outside. But in Python, you don't need to create this ahead of time. You can kind of create it inside of this block, and it's still going to exist within the function scope.
Are functions hoisted in Python like they are in JavaScript?
Absolutely great question. Hoisting. So hoisting is a weird word. The answer to that is no. In Python, functions and variables are not hoisted. So you guys might wonder what the hell hoisting is. Definitely worth going over. So I'm glad you brought it up, Reno. Let's go back to my split view, or let me just bring up my JavaScript here. All right, so hoisting is the concept of you can define something later on, but still use it before that. So what I mean by that, let's say I swap the order of my logic here. So in this case, I'm calling the is greater than 5 function on line 3 and line 5, but I only define it below. So I'm calling it before it's actually defined. In JavaScript, that's okay. Basically, that's where hoisting comes into play, where the definition or declaration of this is going to be hoisted so that when it gets called, it will still be available. So if I ran this quickly, node hello.js, but totally works. That's because this function gets hoisted, so it's accessible when it gets called here. In Python, however, that is not the case. So if I swap the order here, and I put my function below, notice that VS Code's already giving me yellow squiggle lines. So there's likely an error there. Let me get rid of this other error. Oops. Okay, so I'm trying to call my function, but my function is defined afterwards. In this case, yeah, Python does not support hoisting. So I do Python hello.py. Notice I get...
You did 2 periods.
Okay, so notice I get my func is not defined. So at this point in the Python file, it's like, I have no idea what my func is. You're trying to call something that doesn't exist, so I'm going to yell at you. Yeah, so absolutely great question, Reno. I'm glad you asked that. So just be aware of that, subtle differences between JavaScript and Python. Okay, while we're on that topic, let's just kind of cover a few more differences between JavaScript and Python. So Python has a much larger library that's kind of built into it. So again, it's just easier to get up in coding. Python was designed to be an object-oriented programming language. Again, that's a kind of a big word there. We're going to get into object-oriented programming, or OOP, next week. But Python was kind of built for that. JavaScript does support some object-oriented programming, but it wasn't really developed in that manner. It's kind of like shoehorned in there later on. You could create classes in JavaScript now, but that wasn't always the case. But Python, again, was meant for object-oriented programming. Python is more, I guess, strict about a lot of things. So JavaScript is very flexible in terms of you can call a function, for example. Let's do a quick example. I have my greater than 5 function. Let's say I pass an extra value. I'm going to pass it, I think I had y created at some point. Right? If I want to pass it y, this is totally fine. JavaScript's going to be like, all right, you're passing me 2 values, but my function only takes 1. No big deal. JavaScript will let you do whatever you want to do. So JavaScript, again, gives you a lot of flexibility, but that's also can be dangerous. Like if I really need to use this y value and I assume my function takes it in, JavaScript is not going to notify me that something went wrong or something that could go wrong. So I do hello.js. Notice everything works as JavaScript expected to. This extra parameter just got thrown away. If I try to do that in Python, that is not going to happen. So if I do, let's say, y here. All right, so I'm going to try passing 2 parameters to a function that only takes 1. Let's see what happens here. Python hello py. Yep, get an error. So I would argue that this is better, that Python is better in that it tries to catch these errors for you versus JavaScript. It's kind of just like, all right, no big deal. I'll try to do what I can. I'm not gonna, I'm not gonna complain about it. It's good to get these errors because if me as a developer was passing 2 values here, I would expect it to be used. So I'm glad that it told me, hey, there's some error here. You try to pass it two parameters, but only one's required. So it's good for me that I'd be like, okay, maybe I need to add the parameter here, or maybe I don't need to pass it here. I want to catch that early on rather than just having it function and not see that there's an error there. So yeah, again, Python's much more strict about those types of things. It's going to warn you and get more errors, but that's actually a good thing in my opinion. Likewise, there's more exceptions. So if you try to do odd things in JavaScript, usually those exceptions will be thrown away and JavaScript will just continue on. But in Python, you'll see those, your application will get an error and abort in certain cases. What else? In Python, there's no undefined type. So we're going to talk about data types, but in JavaScript, we talked about, or Tom mentioned, there's undefined. Without all these typos, of course. Undefined is a type and null is a type. In Python, there's no undefined. There's a none type, which is equivalent to the null in JavaScript. So just slight differences of like that. Other differences that you get to be aware about. In Python, there's only the double equals versus in JavaScript, we have the double equals versus the triple equals. So just a reminder, triple equals means compare the exact types and the values. The double equals will sometimes convert or coerce a value into another. So you could do something like, 3 equal 3. This will actually evaluate to true in JavaScript. The triple equals will obviously protect you here. So if you did not want these to evaluate to equal, you'd use a triple equals. In Python, it automatically does triple equals for you. So if you try to compare a value of a string value of 3 to a numeric value of 3, Python is strongly typed, which means it knows those are different types, and it's going to say those aren't equal. Okay, just want to highlight a few other differences there while we're talking about hoisting. But let's get back to our focus on Python. All right, where were we? So we talked about variables. Any questions on variables? Again, you just create it, don't need a keyword, create it and use it. You can assign a string and then change it to an integer, that's gonna be fine. Other languages, if you're familiar with C++, that would not be allowed. Like once you create a variable that's an integer, it's always gotta be an integer. Whereas in Python, you could store a string and then an integer, then a list, whatever. It's kind of flexible that way. All right, let's talk about primitive data types. So here we have some primitive data types highlighted. I'm not gonna type these in, but Boolean, true or false. Again, same thing exists in JavaScript. So Boolean can have a value of true or false. We have integers. We have floats. Floats are just decimal values. And then we can have strings. So strings can be single quotes or double quotes. So let's actually just get some coding here. So donuts, we could also do, E equal donuts. That's totally fine. These are interchangeable. The reason we have multiple is because if you want to include quotes within quotes, you use, I don't know why I have quotations over donuts, but I actually like donuts. So you can nest quotations like that. Nothing too crazy going on there. Let's talk a little bit more about strings before we go on. So if you remember in JavaScript, you could use string interpolation. You could do the same thing in Python, just a little different format. So I have my string, let's call it S equals some string. Let's say I had a variable. So let's say my number is 42, 43, 42, 43. All right. Let's say I want to add this into my string. To do that, you add an F before your quotation marks. So F just stands for formatting. And then you could use your variables in here. So if I wanted to add num in here, that totally would work. So then if I printed out the value of S, I should get some string 43. All right, let's verify that. Make sure I'm not making things up. All right, we got some string 43. So again, you had to put an F. Seems kind of weird, but you put an F before any string, and that just means you've used variables inside of it with curly braces. All right, so you don't have to use backticks in Python. You could just use the F formatting so that it works like
that. Could be any expression.
Yep, you got it. Yep, so if I want to do num plus 1, that works. So this should be 44, I expect. Yep. If you want to have ternary in there, you can, but it's got to be a single expression. You can't have like an entire function that you create in here. You call a function, but you can't create a function in these code braces. Okay, let's continue on. So those are primitive data types. Primitive means they're just very basic building blocks, but then we also have non-primitive data types, also called data structures. I usually refer to them as data structures, but they are considered data types. Here we have very similar items that we've seen in JavaScript. We have list, which is equivalent to array in JavaScript. So list is ordered. So that's something we encountered for our Roman numerals challenge, where I wanted some ordering to my data. That's where you want to use lists. So if I have a list like this, all those values will be ordered. I think I did a poor example here because these are sorted. Lists are not sorted, so these values can be in any order. So let me copy this. Again, lists use square brackets, just like you would for arrays in JavaScript. Let's actually change some of these values around so they're not necessarily sorted. I don't want to make it appear that they have to be sorted. Okay, given what I have here, you could print out indices. Indices are accessed in square brackets. So square brackets 4 will get you the 5th item. Again, list values are 0 base. So if I did 0, 1, 2, 3, 4, I would expect this should print out 2. All right, let's just do a quick quiz of what I have over here. What do I have? I called on. Jung, if I can ask you, what do you think line 5 will print out? I know it's a little complicated.
5? Oh, no. 5. Oh. Hold on.
Yeah, I know. So I created this other list, and it has, you can have different data types. I guess that was the main thing I was trying to highlight here. You could have, mixed.
Oh, okay. Oh, sorry. I didn't see that. 0, 1, 2, 3. Oh, okay. 0, 1, 2, 3. Oh, 4. I'm sorry.
Yep. Okay. I would agree with you, but yeah, sorry, I kind of glazed over what I was doing here. So I created my other list here just to highlight you can have multiple data types in the same list. So I have an integer mixed with a string with another integer. I have a list embedded within the list. That's totally fine. I have my original list embedded here, another string. So let's give this a run. Let's see if Jung was correct. Python, hello. Sorry, the first one was from here. But yep, we got a 4. So correct, you were correct there. Good job. So we had a 4. Does anyone want to take a stab at the next line? What will print of my other list index 4, index 5 print out?
Expect a 3.
I think you are correct. Let's do that. Yep, 3. So just to highlight what's going on here, maybe I should have talked about the first one also. So here we have my other list 3. This is getting the 4th item because again, we're 0 base. So we go to the 4th item. We go 0, 1, 2, 3. So the first part of this is pointing to this item. The second square brackets is going to be accessing an item out of this list. So that's also the 3rd index. So we go 0, 1, 2, 3. So in this case, all these values are 4s. So it's not really exciting. But in that case, it's pointing off this 4. So this 4 is the actual value that got printed out. For line 6, we're doing index 4 of my other list. That's going to be 0, 1, 2, 3, 4. So now we're accessing my list, which I created above. And then we want the item at index 5. So if we go 0, 1, 2, 3, 4, 5, whoever shouted out 3 was correct. That's how we get the 3 out here. Next one, who wants to do line 7? What will my other list index 5, index 4 print out?
Gonna be an R.
Let's give that a go. Yep, we got an R. So this is something I didn't mention in my talk about strings. You can effectively think of strings as an array or a list of characters. They behave very similarly in that you can index strings. So that's kind of what we're got going on here. We look at index 5, which in this case is going to be Oscar. And then we're grabbing a value out of it. In this case, item 4 is going to be this R. So a string has indices in it. So index 0 is the O, index 1 is S, then C, then A, and R. So that's something important to keep in mind about strings. They can be accessed via indexing. Yeah, we got the R because that's at index 4. And then finally, what's the last value you're gonna print out?
Would it be none?
Out of range.
So I heard two answers. The correct answer, yeah, you will get an error. So this is another difference that we talked about between JavaScript and Python. In JavaScript, this will be an undefined value because we're accessing something out of bounds. So this is index 5, sorry, index 5 of 5. We're trying to access beyond the string. So in that case, it doesn't exist. In Python, that's not going to be kosher. So it's going to give us an error, which is good, I think, because I tried to access something that didn't exist. In JavaScript, you get undefined, but your application will continue on as if nothing wrong happened. Just be aware of that. In Python, you're going to get these errors, but it's a good thing that you're seeing these errors. All right, so that kind of just covers lists. Again, lists can have lists within it. You could have dictionaries in it. You could have pretty much anything within lists, so long as you can kind of, navigate it. So it's not easy. Like, again, looking at this, you got to kind of parse it piece by piece. Don't try not to having too many nested lists within lists within lists. It just gets complicated, kind of reading it and working with it. Okay, so those are our lists. Next up, we have tuples. So tuples are essentially, you can think of them as equivalent to lists. There's only one main difference that I've noted here. Tuples are immutable. So there's a concept of mutable data types and immutable data types. Tuples fall into the immutable category. This means once you've created it, you can never change the value of that tuple. So running this, I have my list here. Let's give this a go. Notice I have my list here. I changed the value at index 1. So originally both of these are lowercase. I want to change this B to a capital B in my list, and I print it out. That's why I get this B over here. I try to do the same exact thing for my tuple, but this is going to give me an error. The reason, again, just to reiterate, tuples are fixed. Once you create them, they're stuck. You can't modify. I can change my variable if I want to. So for example, if I want to say, my tuple equals a new tuple, this is fine. This is reassigning the value. But the original tuple that I created is, again, immutable. It's going to remain the same. So I can do this. This is totally fine. I'm not going to get an error for that. I could change this to, again, a different data type. I could change this to like a number. Again, Python is not going to care about your variable type. You can change types freely. It's not going to matter. All right, so tuples, you're not going to see them too often, but just be aware they exist. They can be useful. I'll show one case going forward. But otherwise, tuples effectively work the same way lists do.
I see it says that they are ordered.
Yeah, so when we say ordered, that means, this terminology to be aware of, there's a concept of sorted and there's a concept of ordered. Those might seem similar and they're easy to mix up. Ordered means that you're guaranteed to have an ordering, as in the way you insert it or the way you specify the data is going to be accessible. When we say ordered, that means you can index them and there's going to be an expected value. So since I created my list of A, B, C, the ordering when I iterate through this is going to be, my first item is going to be A, then B, then C. But if we go back to early on this morning when we were talking about that object I had created, there was no ordering there. Even though I had specified I wanted my largest increment to be at top, the ordering was not preserved. So objects do not preserve ordering, but lists do. So whatever order you put them into the list, that's the order you'll get out of it. So it's fixed. It won't randomly reassign for you. Same thing with tuples. That's not the same for sets when we get down there. They're not ordered. We'll talk about those. But ordering just means there's a guaranteed known ordered thing. Sorting means like higher to lower or like A through Z. That's where sorting comes into play.
So the order could be 1, 3, 7, 11, 2, 6, and it's going to stay that way.
Absolutely. Yep, you got it. Yep. So it's not going to auto sort. So my apologies here. Like this was pre-sorted, so that doesn't have to be sorted. This can be in any order, which I have down here, 1, 2, 12, 5. Yep. Any ordering you want, so long as knowing that ordering is going to be preserved for you. Then we get down to dictionaries. Dictionaries are very, very similar to objects in JavaScript. They're key value pairs. They look pretty much the same. So to create a dictionary, you use curly braces, and you have a key value and then a value. So we could grab this code and kind of examine it quickly. All right, so my dictionary, I create a dictionary. Notice you can have variable data types as keys. The only thing to keep in mind for keys, they must be immutable data types. That's where tuple come into play. So notice I have a tuple as a key. That's totally fine. However, if I tried to make this a list right here, I would get an error. So let's try running it with a tuple. Clear, run this. Okay, I got yummy and Oscar Platoon because I'm printing out the value of donuts, which is yummy, and new key, which was Oscar Platoon. But if I, as I said, try to change this to a list, lists are mutable, and that is not allowed as a key type. If I try to run this, notice I got unhashable type list. That's because lists are mutable. All right, so that's where tuples can be useful. Again, I'm not sure why you'd want a tuple as a key, but it might be useful in certain cases. Yeah, so those are, again, dictionaries, very similar to objects. If you understand objects in JavaScript, you shouldn't have any trouble getting familiar with dictionaries. Okay, and then we have something called, oh, was there a question?
So square brackets for lists, parentheses for tuples, and curly brackets for dictionaries.
Yep. Yeah, I think I kind of glazed over that for tuples. Tuples, yep. When you're defining tuples, you use round parentheses. Lists will be square brackets, and dictionaries will be curly braces. Thank you for mentioning that. When you're accessing values, though, you will use square brackets, just like you would do with JavaScript objects. As noted, you could add keys after you define your initial dictionary. You could add keys freely. There's no limitation there.
Can you also use dot notation?
I don't believe you can. So if I want to do something like my dictionary.new key, it won't work. Like even new key. Yeah, dot notation won't work in this case. So that is a difference between JavaScript objects and Python dictionaries. There are ways to access the key beyond square brackets. I think keys. Yeah, you can't use a straight up dot notation to answer the question simply, but good question. Yeah, so there are some differences between objects and in JavaScript and dictionaries here, but for the most part, you use them in the same way to keep the same data that you want. Okay, the final one we're talking about will be sets. Sets you probably won't see too often, but they're good to know about. In some cases, they can be very useful. So sets are a little different than lists in that they will throw away duplicate values. So if I had a list, like so, my list equals 1 or numbers. In this case, I have one a couple times, I have 2 a couple times. That's totally fine in lists. You could have duplicate values. In sets, those get removed out of it. So in this case, I have this weird looking set. When I print it out, notice it doesn't have all the values I had initially. It has each unique value. And that can be very handy depending on what algorithm you're trying to implement. Sets can be useful. So just be aware that they exist and what they do. But the ordering is not guaranteed in sets. So let's say I create a set here. So I created that set. Let's see what my output is. So it looks like it's like auto sorting my set. So I created a set of 2, 3, 6, 1, but the 1 came first. I would not rely on ordering for sets. I don't know if they're always sorted, so that's something I would need to double check. I know in other languages they are, but in Python, the only thing sets are doing for you is guaranteeing you uniqueness. They're not guaranteeing any order or anything like that. You can do kind of cool things with sets. So if I did something like s equals hello Oscar, you could throw that into a set. So let's say new set equals, is this what I want to do? And then print new set. Notice, so I get all the letters that are unique in that string. So there's 2 O's, but only 1 O got printed out. So again, if you're trying to determine like uniqueness, that could be handy. You can convert lists and strings or whatever else into a set pretty easily. All right, so just be aware of sets. You probably won't see them too much in our program, but they can be handy at some points. All right, I know we're running into lunchtime, so I don't want to take up your lunch block. Let's break for lunch here, and we'll complete the rest of this. There isn't too much to go over. It's basic control flow, some keywords, some other unique things in Python. But yeah, let's take a lunch break. Let's regather at 1 o'clock, and then we'll finish this lecture up. Before we break, though, any questions initially of anything we went over? All right, I'll take that silence as you guys are really hungry and want to get to lunch, or if there's any questions, we can obviously tackle them after lunch. All right, so I'm going to stop, pause the recording here.
I think you're muted there, Angkor.
Yeah, you muted still.
Ankur, you're still muted.
Gotcha. Thank you so much. All right. That's what you guys were saying. All right. So basically, yeah, I was asking if there's any questions from the material we went over before lunch. So anything about the basics of syntax, basic syntax of Python. Again, we use camel case, so just be familiar with that. Tabs and new lines delineate new blocks of code. So it's a little different than JavaScript. Just kind of get used to it. You will probably run into some issues where you get like indentations are kind of off and doesn't quite work the way you expect it to. So just, yeah, get comfortable with that syntax. Again, I really like working with Python. It just seems quick and easy to work with. So hopefully you guys get comfortable with it soon enough. Yeah, so we went over just the basic syntax, comparing it to JavaScript. Again, we use tabs and new lines for blocks of code. Variables don't need to have a let keyword or a const keyword or anything like that. Variable types, we can have global variables, local variables. Primitive data types. So this is where we get into talking about immutable and mutable types. So all of our primitive data types are immutable, as in you can't change the value of one of these types. So what I mean by that, if we hop back to my coding window, like let's say we have a value of x equals 4. I can change the value of x because x is a variable. So if I want to reassign it, this is totally fine. Again, I could change it to a string or assign a string value to it. Again, that's totally fine. I'm changing the value of x. The key thing to keep here is the value of 4 will never change. 4 is always going to equal 4. 7 is always going to equal 7. So you can't do something like 4 equals 8. Like this is assignment. This is not going to work. Like I actually don't think this will be an error. So if we try to run this code, Python, okay, we do get an error. So this, like, we're trying to change the value of 4. That's not allowed. This is because 4 is an immutable value because it's an integer. Same thing with strings. So strings are actually immutable. So this is one way that strings and lists are a bit different. Like you could work with them in a similar fashion. So if I do something like, I have a string for donuts, and then let's say I have a list. So my list will be some, we can make them letters. Okay, so I have an array of string characters and a string. So both these kind of work similarly in that I could do something like print out, let's see, str. If I want to print out this u, that'd be index 3. I could do the same thing for my list. So if I did my list and want to print out index 3. Okay, so you can access values in the same manner. You can iterate over them. So we haven't gotten over into for loops, but you can iterate over strings the same way that you iterate over lists. So let's kind of introduce that, and we'll talk about for loops more. In Python, you could do something like for C and string. So I use C for character, but you can use whatever you want there. Print C. So this can basically go through each character in my string and print out each value. Same thing for a list. You do for, x in my list, print out x. Again, these are just variables I'm creating, so I can name them whatever I want. This is the same thing. You iterate over each character. Same thing for my list, since they have characters. I'm going to iterate over them. Okay, so the one difference, as I was trying to allude to, is that lists are mutable. strings are not mutable. So if I have a list here, my list, I want to change a value. Let's say I want to change, I want to make this really flexible. Whatever. If I want to change the first letter to be something else, I could do, I don't know, I can't make another word out of this. That's why I planned this poorly. Let's make it an M. All right, I could assign to this and print it out. So if I do print my list, sorry, I have a lot of print statements out here. Let's go through them. All right, so not kind of easy to read, but this U is coming from this print statement. This L is coming from this print statement. And then I have a printout of donuts, because that was what this for loop's doing. And then I also print out title here. Let me get rid of these for loops and make this a little simpler. All right, so I got the U and the L again from these two print statements. When I print out my list, I get mittel. That's not really a word, but that's because I changed the first letter to M. So if I print out my list beforehand, it's going to be title. Let's make this a little different. Stay on the dessert theme. And then if I make that cookies, I can make that a B. So, all right, so we get cookies and then bookies because we changed the letter. However, you can't do this with strings. If I wanted to do something like SDR donuts, let's make that, I don't know, I guess I can't make that into a real word either. Let's say I want to change the first letter into M. Let's see what happens. Okay, notice you get an error. It says str objects does not support item assignment. That's because strings are immutable. Once you create a string like donuts, that string object is going to remain donuts forever. It's just like number 4. Number 4 is going to always equal to number 4. You can't modify the value of 4. You can't modify the value of a string. Again, I could reassign the string to anything I want. So if I wanted to change that string to be ice cream, that's totally fine. Again, it's just a variable. You could store whatever you want into variables, but you can't modify the value itself. So strings, this is true in JavaScript also, you usually just build a new string from the original string. So you could do something like plus equals. This isn't actually going to update the existing string. It's going to use the existing string and then add on to it. So plus equals, if you guys remember, let's add a x, whatever. So now I get donuts and I get an X appended to it. It's not actually updating the initial string. It's creating a new string because this operation is actually doing str plus X, right? So it's taking the original string, combining a new letter to it and creating a new string out of these two, and then assigning that new string back to str. All right, so that's just a thing to know about immutable objects versus mutable objects. In JavaScript, if you try to do something like I was doing before, this would actually fail silently. So if I try to do, I think it was M in JavaScript, this would make you think like it's doing something, but it's not going to actually complete it. So if we want to quickly verify that, I know we're jumping between JavaScript and Python a lot. I want to focus on Python. Let's create a quick string. So let food equal donuts. Let's do console.log for donuts, for food. And then let's try to change the value of food. So let's make the first letter an M, and then console.log. All right, so looking at this code, I would assume that either this should fail or I should see monuts instead of donuts. If I run this in Node, I get hello. Notice I get donuts both times. So this is, again, another reason why JavaScript can be dangerous. When you think something is actually working, but it doesn't actually do what you expect, you can get into trouble that way. So just be aware of that. In JavaScript, you're less protected, but that gives you more freedom. So it's a trade-off, right? But in Python, it's going to catch you and tell you, sorry, there's a truck outside my window.
seen string assignment before. Was that Java that you can do that in?
Sorry, Sarah, your mic is a little low. If you can increase the volume of your mic.
Can you hear me?
It's really faint, but I could kind of hear you. Yeah.
Let's see if I can increase volume here. I'm not sure how to increase the volume. I guess.
Okay. I mean, I can hear you though. What was your question?
Okay, I forgot this thing out of the headset.
Okay, there you go.
I swear I saw a string assignment in another language. I think it was Java.
Yeah, I'm not too familiar with Java actually, but I know in C++ you can update strings. So this is different between different programming languages. You might get some different behavior. In C++, you can modify strings in place. You don't know how to create a new string for it. So
Okay, yeah, maybe it was C++.
yeah, I think Java might have something called string builder, which you would use to kind of build strings. So I think Java kind of acts like JavaScript. Yeah, again, just be aware different languages might do different things. So this is very specific to Python and JavaScript as we're talking about it. Okay, so that should hopefully cover our talk about variables. Again, we talked about data structures. I think hopefully you guys have a good understanding of them. Any questions, please feel free to ask. We want to make sure everyone understands working with data structures. Again, lists are used with square brackets to define them. Lists can contain any data type. There are ordered collections. And again, let's understand the difference between ordering and sorting. Sorting means it's like A through Z or 1 through 10 in that particular sorted order, versus ordering means that whatever insertion order that you have is preserved. So if I add new values to a list, let's kind of clean this example up. So I have my list. I can append to it. I guess that's something I didn't cover. Append. So if you want to add something to it, you totally can. This is the same thing in JavaScript where you do a push. Instead of .push, you do .append. So if I want to do cookies and add a X onto it for whatever reason, that's totally fine. Print my list. Okay, so we added that X successfully. If you want to take something off, it's same thing. It's .pop. So we've seen this in JavaScript, so I'm not going to go too much in detail. But again, very, very similar to arrays in JavaScript. So you guys shouldn't have too much trouble with lists. Then we have tuples. Again, we talked about tuples are essentially the same thing as a list, except you can't modify them. They're immutable. So ABC here, you can't actually assign a value there. You'll get an error. Tuples use round brackets. Lists use square brackets. Dictionaries use curly braces. And I didn't mention this explicitly, but sets also use curly braces. And you might be like, well, how do you know? Like, the language is smart enough to know if you have key value pairs, it'll make it a dictionary. If you just have individual values separated by commas, they'll know that you're trying to create a set and not like a dictionary with empty values or something. All right, so that covers
a dictionary with a set with inside of it.
Oh, say that again, Reno.
Are you able to have a dictionary as a set for like a key or a value?
Yes, you can have in a dictionary, your values can be anything. So you could have it as a set. Sets are mutable, so they cannot be used as keys. So as we talked about, like I can't use a list here because I'll get an error. Your type has to be hashable because dictionaries are also called hashes, just the way they kind of store data. So sets, since you can modify them, I can add new values to my set. So that would not be a sufficient key because keys are not supposed to be able to be changed. Does that make sense?
Yes, thank you.
Okay, but yeah, I can totally have a set here. So notice I have a list as one of my values in this dictionary I created. That could be a set, that could be a tuple, that could be another dictionary. You could have dictionaries within dictionaries, just like in JavaScript, you have objects within objects. As far as you want to go, usually you don't want to have too many nested objects because it gets a little hard to work with. But all right, so those are our data types. Let's get into control flow. So we have our three buddies. We have if statement, for loops, and while loops. So let's talk about if statements. These aren't too different in Python. So we have the simple case. If we want to just do a simple check, we do an if, and then we can do an else. Notice these colons. I always, not always, but I have a bad habit of when I'm typing, I forget to add these colons, mostly because I'm used to like JavaScript and C++ syntax. But notice you gotta have these colons to start the blocks of code. So in this case, my if condition and if body are divided by or separated by a colon and a new line and a tab. So again, this will take an x value and print out, the value of x is greater than 5 if that's true. Else it'll do whatever else I want to do. A slight difference when you're dealing with more complex if statements is instead of using else if, you will use elif. So that's something you get used to. It's easy to kind of swap that up with JavaScript. I always catch myself writing else if. I think this is just to make it a little easier to type. Again, not really a huge optimization time-wise, but just be aware that you want to use elif for an else if statement rather than actually typing out else if. All right, so in this case, we have animal equals dog, so it's going to go through this. It's going to check, is animal equal to cat? Nope. Then it's going to go to the next line. Is animal equal to dog? Yep. Then it'll print out wolf. And then the rest of these won't execute because we hit one of these. All right, so he's going to go from top down. Once it finds a match, it'll execute. If it doesn't find a match, then nothing will happen. I guess in this case, the else case will happen, sorry. Okay, so if statements, hopefully everyone's pretty good with those, but if not, please do ask. All right, for loops. So for loops are a little more different between JavaScript and Python. So we have a basic loop here. Notice we're using a range function here. This is something built into Python. Range actually will create a range object. So if you want to see what that actually looks like, let's have a look at it. So if you want to do a print of a range. So range can take in any number, sorry, not any number, a variable number of inputs. If you just give it one input, it's going to start your range at 0 and go up to 10, non-inclusive. So this can go to 0 through 9. If you want to start at a different value, you would give it two values. You give it a starting value. Let's say I want to start at 3, and then I want to go up to 10, not including 10, and I could specify two values. Also, you could specify 3 values here. The third value would be your step. So how many increments you want to do between each iteration. So in this case, if I have a range of 3, 10, and 2, I would expect that output to be 3, 5, 7, and 9. So let's actually verify that instead of just guessing at it. Okay, so notice my range. I guess that didn't actually create a range object for me.
Scroll up.
That just printed out that.
You didn't have a print statement for the first one.
Let's try this. All right, I guess I thought it would actually show me the range, but I guess it keeps it as a range object. So this is actually a range object, this range. So if I actually do something like, so type can be used to try to investigate what data type you're working with. So if I do that, I get class range. So this is some special object that's being created that has some properties with it. Anyway, if I actually want to use that range, which is the more interesting part. All right, so this range is going to start at 3, go up to 10, not including 10, and then print out every other value. So if I go run this, I get 3, 5, 7, 9. Again, just to reiterate, the number, your ending number is non-inclusive. So in this case, this 11 still won't be printed out because this will stop between 3 and 10. So I go that again. Notice that 11 was not printed out because 11 is non-inclusive in your ranges. So if I, again, have one value, so let's say I use 11, this should print out every value between 0 and 10. There we go. So 0 through 10, like I would expect. If I want to increment, I could go by, I don't know, 4s. It's not going to print out that many values, but I get 0, 4, 8. So again, you'll see this often. This is the most common type of for loop you'll see using the range object, because you use for loops when you know how many iterations you want to do, versus you have while loops. Again, hopefully you guys have used while loops in JavaScript. While loops are usually used when you don't know how many total iterations you need to do. You might need to do 1, you might need to do 1,000 or infinity. That's when while loops come in. For loops are done when you know how many iterations generally you need to do. So that's a basic for loop. Let's make it a little more let's get some other examples here. So we talked about iterating over a list. Use the in keyword, and this will basically go through every item in your list and print it out. So that's nothing too exciting. This will just go through each item. Again, lists are ordered, so X will go in order A, B, and C. One thing that I did want to mention about dictionaries. So let's create another dictionary. Let's add some values here. So let's have donuts as a string. Of course, those are yummy. Let's have an integer, 7. That just be 7. What else do we want in here? Let's put another number. Let's put 4. Let's put another string. How about cookies? Also tasty. Okay, so one thing about dictionaries, and this is sort of recent to Python. Originally, dictionaries did not have a default ordering, but I think as of Python 3.5 or 3.6, dictionaries did adopt ordering. So if I did print this out, I can tell you what the ordering will be, even though it's not going to be in this particular order that I set it up as. And that was a mouthful, and I probably confused you guys, so let's just talk about it as I print it out. All right, my dictionary, let's get rid of these loops. Okay, that's all right, 4 X in my dictionary. Print X, print my dictionary. Okay, maybe I'm getting JavaScript confused, I apologize. Clear. Okay, yeah, so it looks like insertion order is preserved for dictionaries, so that's good to know. I think in JavaScript, these items kind of get jumbled. All right, so notice donuts were first, so I get donuts as an output here. Second up was 7, so 7 is my second set. So it looks like insertion order is preserved for dictionaries. That's sorry, I said that incorrectly before. So that's good to know. So Python does that a little differently than JavaScript. Insertion order is preserved. All right, so you can loop over dictionaries just in the same way that you loop over them in JavaScript using the in keyword. You get the key, and the key can be your accessor for what you're trying to get. But there's a couple other ways you can do that. So let me, I guess I did have a dictionary down here. You could use this enumerate function with lists. That will give you an index value. So this is something that, again, with JavaScript, when you're using for loops, usually you have that iterating value. For basic loops, you don't always have that. So if I do a simple for X in my list, which my list has no longer seems to exist. Okay, so I have my list here. I want to print out values. My list. Okay, so if I did it this way, I can get these values, but I don't know what item I'm on with this basic for loop. That's where you want to use enumerate if you actually need the index. That's what I have I standing for index. Again, this could be named index or whatever you want it to be, but sometimes that can be useful to have that index value. But there are still some limitations here. I can't really modify this index value for this iteration. What I mean by that, if I go back to JavaScript, just to compare, our for loops often look like, let I equal 0, I less than, create an array. Okay, I have this simple array. My goal here is to go through this array. All right, so this is what we're used to for loops in JavaScript. So we have create our iterator value. We have an ending condition. and then, or sorry, a continuation condition, and then we increment. So if I want to do something like if my array at I equal, let's say B, I can control the value of I here. So let's say I want to jump ahead. Let's say I want I to equal my array dot length -1. All right, so in this case, if I ran a for loop like this, and let's say I have a console.log, can anyone take a stab at what this will output for me? Okay, so in this for loop, we're going through my array. The very first time I is going to equal 0, so it's going to print out an A on this console log here. Second time around, I is going to equal 1, and then we're going to check this if statement each time. In the second case, we're going to print out B, and then in this case, the value is going to equal B. I probably need triple equals just to be safe, but this is going to actually be true. So in that case, I'm going to update my I value. It's going to jump all the way to the last index, which is I -1, or the length -1. So in this case, it's going to print out A, print out B, and then this if statement is going to make it print out E for the next iteration. Actually,
And it does exit the loop.
sorry.
Wouldn't it exit it because it,
Yeah, you're right. You're right. Sorry. Yep, you're right. That'll cause us to exit because we'll iterate after that. So if I did something like I -2, that's the case I was trying to imagine up here. All right. Node. Okay, yep, so we got A, B, E. You guys were right. My apologies there. So if I change this to the very last value or even some value greater than it, it'll exit the loop after A and B. So I get A and B. So if I want to do something like this in Python, it's a little tricky. So I can get the index value, but I can't modify it. So if I try to do index, equals 5, let's just make it 88. Let's see what happens here. So I have my list. I'm printing out my list here. We'll get rid of that. So again, X will be the actual value. Index will be the index from the list. So let's see what happens. Python. Okay, so notice the first value is my index. It didn't change. I assign it here, which is fine, but it gets reassigned up here. I didn't skip over any values because this index is only being read. It's not being, it's not controlling my loop here. So if I want to do something similar to what I was doing here, so let's actually just copy our array from before, make those characters. So we have A, B, C, D, E. It's a little trickier to get that to work here. So let's say I wanted to print out the E. So this case, right, that I had before. I want to print out A, B, and E by kind of skipping through a couple values here. I can't do that with a basic for loop here. So the usual way you want to accomplish this would be with a while loop in Python instead of doing it as a for loop. So that's just something you got to be worried about if you need to modify where you're iterating. Otherwise, for loops will always go through all the indices normally. All right, let's go back to iterating over dictionaries. So I have a simple dictionary here. Donuts are yummy, green beans are icky. You can iterate over them by just going for K in my dictionary. So K stands for key. So that's why I've called it K. So you just get the key and then print out the values if you want. Or you could just get the values directly if that's all you care about. Like if you don't care about the keys, you could do something called like mydictionary.values. There's also mydictionary.keys and mydictionary.entries, which give you both key value pairs. So if I want to do for K, V in entries, I think. Print K and V. All right, let's see what all this prints out. All right, we get yummy and icky. That's from this first for loops. Second one, we get yummy and icky. All right, entries is not, I think it's items maybe. All right, there we go. So sorry, it's items to get both the key and value. So in that case, I got the key, which is donuts, and the value for this third loop here, and then green beans and icky. So you have a few options based on what you're trying to do. If you want both, you use .items. If you want just the values, you use .values. Pretty straightforward there, hopefully. Okay, so that covers for loops. While loops are pretty much the same as in JavaScript, so syntax are different. But again, this is where we'd use a while loop if we wanted to simulate what we were doing in JavaScript. So while loops use the while keyword. You have a condition. The loop will execute so long as that condition is true. In this case, when I have x equals 9, it's going to print out 9. I'm going to decrement manually and then keep looping until x becomes 0 or less than 0. You can get infinite loops with while loops. Just be careful. Anytime you're writing a while loop, make sure you have some way of escaping it. So in this case, I have x equals 9. My condition is as long as x is greater than 0, print out la la la. So in this case, my x value is never changing. So it's going to print out forever and ever and ever. Let's give that a go. Notice it's going. If you ever need to abort out of the Python app, you want to do Control D, or sorry, Control D, Control C to abandon any while loop that you're stuck in. Or if your program is just running forever, you need to abandon it. Control C will exit back out. All right, so those are while loops. Let's just kind of try to simulate what we're doing before with a while loop, just to get that practice in there.
Hey,
So
Ankur, I got a question.
Yep, go for it.
Oh, you already deleted it. All right. On the Python, for the x equals x minus 1, you also write it as x minus equal 1. Will that also work, or will that not work because it's different language?
Great question. This is totally legit, except, sorry, not except. However, this syntax is not valid in Python. So you might be familiar with the plus plus or the minus minus in JavaScript. You can't do that in Python. If I try to do something like this, which means decrementing it, you're gonna get an error. So this, again, small syntax difference between Python and JavaScript to be aware of. But yep, minus equals is totally legit here. So we could do that here. This infinite loop we don't want to run. But yeah, let's quickly try to do this. So we have my array. So instead of a for loop, we want to use a while loop. Let's call this my list. So let's do while I is less than length. I guess this is something I should also mention. So to get the length of an object, you want to use the len function. In JavaScript, you do dot length. In Python, you will use len as a function. So this is saying while I is less than my list. So I need I value equals 0. What are we doing? We're printing the value of my list. And then we want to check for a special case. So if my list value is equal to b, I want to change the value of I. So now we can do something similar to what we were doing before. We can control the value of I since I is managing our loop here. So I can equal the length of my list minus 2. Here are your colons, and I would expect this to do the same thing as our previous example in JavaScript. Let's verify that. Nope, we got an infinite loop because I so we still need to increment our I because otherwise I is going to be the same value forever. That was my mistake. All right, there we go. So we got A, B, and E. So again, this is similar to the for loop where we're incrementing each time. This is a special case where we reset I to some value. Okay, so those are for loops and while loops. Again, nothing too new. If you're familiar with them in JavaScript, you should be comfortable with them in Python.
Yeah, Ankur, quick question.
Absolutely.
The way that you used your while loop, when would that be a kind of real world case? Like I know it's to learn how to problem solve and program, but why would you want to go to do what you just did, A, B, and E? Like,
so I guess the case, yeah, the A, B, and E, yeah, that's just a random example. But just to highlight what I said before, you want to use while loops when you don't know necessarily how many iterations you need to do. So like this list theoretically could be 1,000 entries, and I might have like very many special cases in it. If I don't want to go through an entire my entire list, then a while loop probably makes more sense because I could hop around. I could change the I value as I want. Like I could even subtract it and like do some items again. I don't know. So while loop, again, you want to use while loops when you don't know like from the start how many iterations you need to do. For loops are when you usually have like a list and you want to go through it all or have some set number of iterations. That's again when we're using the range, right? The range keyword. So for I in range. So you want to do something exactly 10 times, then you just use a for loop because you know how many times you want to do it. Versus a while loop, and they might be infinite. You never know what you're trying to accomplish. Typical use case for a while loop is you might just have a while true here. Sorry. And then you might ask for some user input. So you'd be like x equals input, enter, and input. And this gets me to my next topic on the page. So we're going to be talking about these keywords. We talked about it in JavaScript. There's the break keyword. The break will break out of any loop. The loop can be a while loop or a for loop, but it'll only break out of that particular loop. So you can have nested loops. It's not going to break out of all of those loops. And we'll see an example of that. For this case, let's say we need a value greater than 7. And we're prompting the user to enter something. We could give that a try. So notice we're in an infinite loop. Input will actually halt your execution, so it's not going to keep asking, but it's asking for a value. So let's enter a value of 4. Okay, so it's a string. We can convert that to an int. I figure out how to do that. So let's do a quick Google, Python, convert string to int. I believe there's a parse string. All right, it's simple enough. Okay, let's enter a 4. Notice we get prompted again because we're in a while loop. This is going to go forever until the user complies with the request. All right, so let's actually enter the number, and there we got out of this loop because we satisfied that condition. So that's again a good use case of the while loop where you might not know how many times you might need to do something. Okay, so going back to our keywords that we're going to highlight, we have break and then we have continue. These are very useful, especially when you're dealing with loops. As kind of we just highlighted here, break will basically abandon the loop whenever you want to. So we have a normal for loop. Here we have a nested for loop. So in this case, we're going through a range of 10 values. In this case, we're going from 10 to 20 and just printing those values out. This break will get out of this inner loop, but this outer loop will continue. Now, these values are kind of high, so it might be kind of confusing. So let's try give this a run. Okay, so let's look at our output. A lot of values, probably too many to know what's going on. Okay, so let's make this a little simpler. 5, and let's go from 6 to 12. Okay, so this is our output. We get 6 because we added the first time for outer for loop, x is going to be 0 because we always start at 0. Then our inner for loop is going to add all these values to x. So the first time y is going to equal 6, x is 0, so we get an output of 6, which is what we see here. Next time around, the y loop is still continuing, x is still 0, so we get y equals 7 because we're going from 6 to 12. So we get 7 plus 0, 8 plus 0, 9 plus 0, 10 plus 0, 11 plus 0. Next time around, once we finish that while loop, we go to the next value of x, which is 1, right? And then we repeat the process here. So we use 6 plus 1, 7 plus 1. That's why we see this section here. Then we have this case here. If x plus y ever is above 15, then we want to break that inner for loop. So let's kind of go deeper into our loop here. So notice when we get to, let's see, 14 here. So like when x equals 4, I guess this isn't the best, let's trim this a bit. All right, so we're never going to get a value, let's see, x plus y.
Can you just break out of that if statement instead of that second for loop?
So break does not impact if statements. They only work for loops here. Right.
Encore. So to break out of that X loop, you would have to write break and before the inner loop, right?
Yeah. So if you needed
Okay.
to abandon both these loops, you would need some additional logic. I'm trying to figure out what's going on here. So,
I
okay.
want to just print a blank line at the end of each loop, so you can tell which is which.
I see. I'm just going to swap these orders. So basically, my goal is not to print out anything greater than 11. So here we go. When we start, hitting 12, as in get above 11, we stop doing this print. So this break, again, we'll break out of this loop, but continue on with this one. So yeah, I probably should make this a little clearer because these numbers aren't really helpful. Let's do prints. Let's make it a little easier for us. Okay, so we have three values we're printing. We're printing out the x value, the y value, and then the sum. So as we get towards the end of the loop, when x equals 4, for example, we only iterate the inner loop twice for y equals 6 and y equals 7. When we get to y equals 8, we're going to break out of the inner loop, but we continue on. So I guess the better case is looking at these three numbers. When x equals 3, y will go through 6, 7, and 8, because that's where we're starting our range. But it's not going to continue beyond 8 because then the value becomes greater than 11, the sum. So then we break out of this loop and then go to our next iteration here. That's why the outer loop continues here. But I think Kyle was saying, or I forget who was asking, I apologize. If we want to actually break out of both loops, you need to add some logic. In the inner loop, you might want to add some Boolean that says, abandon all loops, and then you could use that value to break out of the outer loop. So it gets a little tricky in that case.
I mean, if you're in a function, you can just use return.
Yep. Great point. Okay, so just want to introduce break. We also talk about continue. Continue lets you abandon the current iteration, but lets you continue, as the word kind of implies, the loop. So let's say I had a simple for loop like for x in range. Say if x is equal to 2, continue. And then for all other cases, I want to print out x. All right, so notice this for loop printed out 0, 1, 3, and 4, but did not print out 2. The reason is this continue will basically stop doing that iteration and go to the next iteration that needs to do. So continue, again, will not abandon the loop. It'll only abandon the current iteration, but will keep the loop alive, versus break will kill the loop and proceed on after the loop. Any questions on continue or break? They are very useful. You guys will probably be using them often, so make sure you're familiar with them.
I do have a question on that.
Yep.
What if you did something like in the if statement, if you only wanted to have continue with even values in your range of 5? So if x, I guess, mod 2 equals 0, and then 2 happens.
Yep. So in this case, I would expect 1, 3, 1 and 3 to be my only output. Here we go, 1 and 3. Make that a little more exciting. Yeah, so I didn't explicitly go over operators for Python. They are going to be essentially exactly what you're familiar with in JavaScript, except there is one that I should highlight. So I guess if we're talking about operators, one nifty one is the double divide. So if I have something like x equals 7, y equals 4, prints 7 x divided by 4, x divided by y. This will give me a decimal value of 1.75. If I want only the whole value, as in I don't want the remainder, I could do a double divide. So this is a special operator in Python. You can't do this in JavaScript. Will only give you the whole value. So this will be useful, for example, in Roman numerals, where we had to do math.floor in JavaScript. This essentially does that for us. So it's just much handier. Notice we get a 1 here. So we always get a whole number. Versus we do a normal divide and want the floating point, we can do that. And that's totally fine. Otherwise, like modulo definitely exists. Power, if you want to do power, again, it's the same. I'm not going to do 7 to the 4th power, but let's do, or 77 to the 4th power, but let's do this. So 7 raised to the 4th power will be 401. I'll trust that that's true, but double multiplication is power, same thing in JavaScript. Nothing too exciting to go over with operators, I don't think.
What happens with an error like divide by 0? Does it do horrible things or somehow go on?
It will not go on. So if I have y equals 0, you'll get divide by 0. In JavaScript, I assume that's just going to fly on. But yeah, Python's going to catch that. Divide by 0 is one of those scary cases where it doesn't know how to compute that, so it'll definitely warn you about it.
So if we're dealing with input and dividing by it, it's best to make sure that the input's valid before we go on.
Yep. Yeah, you can never truly trust user inputs. Like obviously, if you're writing an application for yourself, you're going to be interacting with it. But if you write like a professional grade application, that's where error handling comes into play. So we haven't talked about error handling. I will kind of jump the gun here. So Tom's going to be talking about this more on Friday. So if you're confused by this, just wait a couple days. But error handling comes with try excepts in JavaScript. So in this case, if you notice, the first time I did this, I didn't have try except. So I got an error. My application aborted, as in it didn't successfully run. But in this case, I could handle this gracefully. So I could do something like, all right, so try is going to try to do this line of statement. If any error occurs, this except statement will gracefully handle it, and my application will continue. So if I want to do print something else out, donuts are yummy. So let's give this a try and compare it again without the try except. So notice I get 2 outputs. I get oops, there's an error, and donuts are yummy. If I did not have the try except, I will only get one. I would get nothing printed out actually. So I got a division by 0 error. Notice that my print line of donuts are yummy, I guess, and there's an error. That won't you really need that. Nothing else got printed because my application kind of crashed and aborted everything else. Versus if you gracefully are aware of something that could go wrong. So if like y is a user input or some calculated value that could be 0, always try to use try except. So this is something we're going to go more over on Friday, but this is one way we make our code safer. Okay, we're almost done with all of the basic Python introductions. So we talked about the continue keyword, the break keyword. Again, very useful when you're dealing with loops. So just understand how they work. If you don't, definitely just read up on them. Most languages have break and continue as keywords. The final thing are just it's more Python specific. You can have some strange, I guess, syntax. For else is one I'm just going to highlight here. You can have a for else block, which is not possible in other languages, at least ones I'm familiar with. So for else, this else branch will run so long as this for loop complete. So let's try this. So that is something went wrong here.
Your else, so your print statement under else in line 11 doesn't have the closing quotes.
Oh, good eyes, good eyes. Thanks. Yep. Okay. So else will execute if this for loop executes to completion. So let's kind of highlight this with another print statement. And of course, we're just going to donuts are yummy. Okay, so my list has A, B, and C. Let's say we actually have an E value in here. All right, so in this case, we start going through my for loop. We check A, this is not true, so we continue on. We check B, this does not match. Sorry, I got a noisy street over here. Then we check C, that doesn't match. When we finally get to E, we get a match, and then we break. This break effectively says this for loop is aborting. It's not completed. Even though we're on the last element, the break basically bypasses this else. So this break will basically just abandon this entire block and then go to the next line. So that's why I see E is found, and then donuts are yummy. But if I didn't have that E in there, so in this case, this is just the first case, it's going to print out this line because this else block will actually execute because this for loop completed and there was no break that happened. So this break was never hit. So after this for loop completes, else will actually do whatever else it wants to do. So you'll likely not see this. This is kind of an odd paradigm, but it can be useful for certain cases. So again, just as Python specific, there are definitely some weird structures that aren't found in other languages. But we don't need to go too much in detail into that, but just don't be thrown off if you ever see like a for else loop. It kind of takes a while to kind of understand there.
So that would be because you don't have an iterator variable to compare to make sure that it didn't go past the end. It just lets you do it for you.
Yep. Again, this is kind of going back to this. Python is very developer friendly. So they added this paradigm just because I assume it's very, it's handy rather than keeping track of some Boolean here. The normal way this is done in like other languages, I'd have a value saying success equals false, and then this be success equals true. And then outside the loop, I had to check if success, something like not success. So this is a typical case where you have a variable, you assign it, and then you check that variable outside of it. So it's a little less developer friendly. Not keyword, that's something Python specific. So in JavaScript, you would see exclamation mark to negate a value. In Python, instead, it's the not keyword. So again, small, subtle differences like that to get used to. Okay, I think that should take care of everything I wanted to go over to get you guys started with Python. Again, it's gonna be a lot of headaches early on just to know the particular syntax or like the functions that you need to use, but you can easily Google and find your answers for like, if you're trying to do something in Python that you did in JavaScript, it should be pretty easy to find the equivalent function if you don't know it offhand. I gotta add a ending quote there. Okay, so we also talk about code style. Python uses something called linters. So if you go to your extensions, there's probably linters you find. But yeah, Visual Studio Code comes built in with pylint, which is basically just a way that it kind of cleans through your code and formats things nicely for you. So it just helps developers, keep their code clean and easy to read. So when we talk about code style, you guys can kind of give this a read, but the main purpose behind code style is usually you're gonna be working on code with multiple people, as in when you get to your jobs, you'll have large projects. Very rarely you're just gonna be working by yourself. It's good when everyone kind of agrees to the same naming standards. So that's when we talked about going back up to the fact that we use snake case in Python. That you don't have to. Like Python will still compile if you name your variables in camel case. It's just the fact that developers kind of have agreed that snake case is the way to go with Python. So you kind of want to adhere to their standards so you speak their language and it's easier for you to read someone else's code and someone else to read your code. Naming items and like, again, the way you format your code, make sure you use like capital letters for constant variables just because that's the expectation. Again, you don't have to, but following and adhering to style guidelines is very beneficial and just makes you a better programmer. That means people can work with your code more easily and vice versa. All right, so you guys can give this section on linters a read. There's also linters for other languages. So in JavaScript, there's ESLints, but you guys can kind of mess around with that. But yeah, just try to be consistent. It can be kind of tempting to just do things your own way because you're writing your own code, but it's good practice to just make sure you're using the coding styles and coding conventions that are kind of established already. All right, any questions on Python basics? So there are a few more items we're going to go over. On Friday, Tom's going to go over some more, I guess, advanced Python concepts. They're going to be lambda functions, list comprehensions, error handling, which I kind of introduced here, but didn't get too deep into it. So any other like more advanced Python things we'll still kind of introduce, but kind of want to just give you guys a basic intro to Python, get you guys ready to work on the challenges for tonight. All right, speaking of challenges, let's take a gander at them. So notice that these all probably seem familiar because you have done them already in JavaScript. Your task today is go over the past challenges from the last couple nights and redo them in Python. I would highly, highly encourage you not to just take your JavaScript code, paste it in, and then just convert it. I would say just try to code your Python from scratch. Just A, you get that repetition of solving the algorithm, and B, just focus more on Python syntax rather than just like converting. And I feel like you learn less if you just take a piece of code and convert it rather than writing it yourself. All right, so again, 6 challenges. You guys should be familiar with what these challenges are asking for. We're just asking for it in Python. The good thing is in Python, def grammar should be much easier because we have that input command that I used earlier. It's using our examples. So it's just input parentheses. Just go over that one more time. The input function is built into Python. You could prompt the user, and then they'll give you a value. Right, so you get a prompt. This will halt your application, and you'll say, "Hello, Oscar." Here we go. So yeah, def grammar should be easier second time around. Otherwise, you guys should be familiar with these challenges. Just get more comfortable with Python. Again, it's going to be kind of a headache to remember, do I do print or console.log? Do I use curly brackets or just use tabs? Like, that's going to be part of the frustration, but hopefully you guys get familiar with both languages by the end of this week. Okay, that's going to wrap up our lecture. So we're hitting 2 o'clock. So for the rest of the afternoon, you guys are going to be working on your challenges. Again, today is not a mandatory pair programming day, so kind of work on it at your own pace. If you do want to find a partner, we're not going to stop you, obviously. But yeah, hopefully you guys get through these challenges. If you guys run into any Python specific questions or errors that you're not familiar with, definitely reach out in the Oscar questions chat, and we'll definitely try to address your concerns. All right. Any other remaining questions?
And then we'll meet back here at 5 p.m., right? Eastern time.